Welcome to Dr. BT's Chemistry Essentials, A-Level Chemistry made easy. In this video we're going to be looking at water recrystallization, so both looking at what the practical involves and then also calculations in order to work out how many molecules of water is in a hydrated crystallized salt. So, as an example, if we took copper sulfate, CuSO4, in its hydrated form, it is CuSO4 with X number of water molecules around it. So hydrated means it's a crystallized compound containing water molecules. In the case of copper sulfate, this is that really deep blue crystal that you can pick up. Now, if you heat this, you form the anhydrous form, where it's just copper sulfate on its own, and this is a white powder. Having heated it, we've driven off the water, so X number of molecules of water are removed from the crystalline structure on heating. Anhydrous basically just means there's no waters of recrystallization. So when you carry out this practical to work out the moles of water that is in your hydrated sample, what you need to do first of all is put your hydrated copper sulfate into a container called a crucible, and we need the mass of that crucible. With the mass of the crucible alone, you then put the copper sulfate in its hydrated form into this, and then you take the mass of the crucible plus the hydrated salt. Then you heat the sample, and you heat until you get a constant mass. And what we mean by this is that the crystals are repeatedly reheated until the mass of the residue, so we would observe this white powder being formed, no longer changes. And once that occurs, it suggests that all the water has been removed. And then final mass reading that we need to take is that of the crucible plus the anhydrous salt. So here we've taken 3 readings of the mass of different samples. And these 3 readings allow us to work out the mass of the copper sulfate hydrated form and the mass of the copper sulfate in its anhydrous form. For example, the mass of the copper sulfate in the hydrated form would be B minus A. We're taking away the mass of the crucible from the mass of the crucible and the hydrated salt, so we're isolating just the hydrated salt here. And then if we wanted the mass of copper sulfate, we do C take away A. If we tie in the practical measurements made with the equation, through B minus A we have the mass of the copper sulfate water. Obviously we've not known what X is, we don't have the MR. With having the mass of the copper sulfate in the anhydrous form, we have the mass here. Obviously we can get the MR of copper sulfate in the anhydrous form because there's no water molecules there that we don't know the amounts of, and that is a value of 159.6. And then with these pieces of information, the mass of the copper sulfate anhydrous and the mass of the hydrated copper sulfate, we can work out the mass of water that was lost. As the law of conservation of mass means that the masses of these two combined should equal the mass of this. So if we do a quick calculation, you take the mass of the hydrated minus the mass of the anhydrous, you'll get the mass of water. And then obviously the MR of water is 18. And so we can calculate the number of moles of copper sulfate and the number of moles of water. Now to demonstrate this, we're going to use some values here. So imagine that we've worked out that the mass of the hydrated copper sulfate is 4.353 grams. That would have been taken at the beginning before heating. And then once we've heated to constant mass, we then got the mass of the crucible and the hydrous salt. And then from there, we could get the mass of the copper sulfate. And we worked that out to be 2.783 grams. So what we can do is, as we said here, we've extracted the mass of the hydrated and the anhydrous. We're going to calculate the mass of the water lost. So we're going to do hydrated minus the anhydrous, which gives us the answer of 1.570 grams. Then we're going to work out the number of moles of the anhydrous and the number of moles of the water. So for the anhydrous, we get the value of 0.01744. And for the moles of water that were removed, we've got 0.0872. The final step here is to work out the ratio between the moles of water that were removed compared to the moles of the anhydrous salt. So it's a bit like an empirical formula. The number of moles of water divided by the number of moles of copper sulfate. And if you ever forget this, it's always the biggest number on the top divided by the smallest number, because you're trying to find a ratio. And this happens in the empirical formula as well, because you always divide by the smallest number of moles in an element. So taking our values there, if we do that calculation, we get the value of 5, which therefore means our formula here is copper sulfate 0.5 waters. We've used our water of recrystallization practical and the different masses that you record in order to work out the empirical formula of our hydrated salt. So what I would like you to do now is to pause the video and just see if you can remember the 5 key steps in working out the number of moles of water that's in a hydrated salt, and then we can start applying it to some questions. So the first question that we want to apply this information to is this question here. So I want you to pause the video and see if you can come up with both the written answer for part I and the value of x for part II. Okay, so the first part here is describe how the students can ensure that all water has been lost. The key phrase here is to heat to a constant mass. Remember from earlier, that is where you keep heating your actual sample, and as long as the mass doesn't change, you know you've removed all the water. Because obviously if there was still water there as you're heating it, that mass should still decrease as it's removed. Now, this is where we look at the calculation. We're being asked to calculate the value of x in this sample here of our iron sulfate. Really useful to first of all think about the equation that's happening here, and then start extracting some of the information. So, we've got here 9.45 grams of our hydrated form. One ticked off, extracting the information for the hydrated form. The second bit is to extract any information about the anhydrous solid after heating. So we've got here 5.16 grams. We've completed the second step, extracting information for the anhydrous form. The third step is working out the mass of the water. And remember, because of the law of conservation of mass, this side of our equation has to equal the left-hand side. We're doing the mass of the hydrated minus the mass of the anhydrous, and that gives us the answer of 4.29 grams. Then step 4 is to work out the number of moles of the anhydrous and the number of moles of water. So we need the MR of iron sulfate, gives us N as being mass over MR. So 5.16 divided by 151.8, 0.034. We do the same approach with water, the MR of water being 18. And so we do 4.29 divided by 18, 0.238. And that stage we have done stage 4. So we just need to do the fifth and final stage. See, that is the number of moles of water divided by number of moles of anhydrous. So we're going to do 0.238 divided by 0.034. That gives us our ratio, because we're just seeing how many times this fits into this number. And that gives us 7. So we know x is 7. Now, it's worth noting that some students quickly learn that obviously x is usually either 7 or sometimes 5, and they think that by putting that down on the answer line that they'll get the marks. You have to show calculations to get any marks in these, because obviously examiners are on the note of knowing that students actually just try and learn the answers. So final exam style question to have a look at. This one's worth 3 marks. I want you to pause the video here and then work out what the value of x is. If you got the value of x as being 7, then well done. Remember, you can't just learn this, you need to show your workings out. So let's talk our way through this. We've been told that Epsom salts have the formula of magnesium sulfate with X water molecules, so that's our hydrated form. When we heat it, we had 25 grams of Epsom salts, and we heated that and then got a solid remaining on cooling. So we know we've driven off these water molecules, so our solid is magnesium sulfate. And we can see here that we have 12.22 grams of that. And then we're left with the water molecules. So 1 and 2 have been done as we talked through that by extracting the information. Step 3, we're working out the amount of water. So step 4, what we then need to do is work out the number of moles of both the anhydrous and of the water. So that's the number of moles of the magnesium sulfate. And there's the number of moles of water. And so the final step here is then to work out X. So that is 0.71 divided by 0.1015 is the answer of 6.995. And obviously that's close enough to 7 as we round up. And so that's our ratio and that's our answer. So in this video, we've been looking at anhydrous, hydrated and water recrystallization, and then using the practical for water recrystallization in order to generate some mass values that allow us then to work out the hydrated salt formula given experimental results. If you found this video, make sure that you like it and then make sure that you subscribe to the channel so that you get new videos as and when they're uploaded.